Hello everyone, you're welcome once again. We are going to continue with our discussion of the IGCSE physics to see how we can broaden our knowledge on the subject. We are considering force, mass, and acceleration today. Already we've considered the effects that a force can have on a body. It can change the shape of an object, it can cause it to move, it can cause a moving object to move faster. It can cause a body at rest to start to move. Now, a body at rest would usually have some form of reluctance to move. And a moving object will usually resist an attempt to change its velocity, that is to cause it to move faster or slow down. This resistance to motion on the part of an object at rest, or the resistance of a moving object to change its velocity when in motion, is referred to as inertia. The greater the mass of an object, the greater its inertia. So, for example, if you consider what we have here in the diagram, we see two objects, one clearly larger than the other. If we consider this object to be one having greater mass and this one having less mass, the object with a greater mass is going to have greater inertia. That is, its resistance to motion is going to be greater than the one with less inertia. So if we assume these to be two blocks, this one obviously is going to be heavier than that one. It will require greater effort on your part to slide this one into motion than it would for this one. That resistance to motion, when it is at rest, that reluctance for the object to move, is what we refer to as inertia. In the same way, if an object is moving at constant speed, it is usually going to resist any attempt to cause it to change its velocity. A typical example is when a person is in a car. But what if the driver applies the brakes of the car very suddenly? There is a jerk, you are forced to move forward because of the inertia that you have. You want to continue to move in a straight line. So if there is a sudden application of the brake, which means you are forced to come to a sudden stop or change your velocity, you are jerked forward because of the inertia. Now, this is usually referred to as Newton's first law of motion. So Newton's first law of motion states that if an object is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. So if the object is at rest like the two blocks that were shown initially, they wouldn't move unless a force starts to act on them, which will force them to start moving. In the same way, if an object is in motion at a constant speed, it will continue to do so unless an external force acts on it. An object would usually have more than one force act upon it. The sum of these forces acting on the object is referred to as the resultant force. I've done a full video on resultant force, finding the sum forces, and the link to it is placed right here so you can check that video as well. So we've come to see that a force can cause an object to start moving or to accelerate. That is, if an object is already in motion, its velocity can be caused to change once a force is applied to it. And we know that when an object changes its velocity, it means acceleration. Now, this relationship between force acting on the mass, which can cause it to accelerate, also brings about the Newton's second law of motion. So the force usually acts on the mass and then produces acceleration. Newton's second law of motion states that the acceleration of a system is directly proportional to in the same direction as the next external force acting on the system and inversely proportional to its mass. Now, based on this law, Newton's second law of motion is usually written as force is equal to mass times acceleration. And we know the force here is the total force acting on the object, or the resultant force that is acting on the object. So then we have F is equal to mass is represented by small m. Acceleration is represented by small letter a. So we have F is equal to ma. And this relation is used very much when we are solving questions on force, mass, and acceleration. Once a force acts on an object, it is able to cause it to start moving, or it's able to cause it to accelerate. And the object will typically move in the direction of the force. That relationship between force acting on the mass and producing some form of acceleration is what Newton's second law of motion is about. So in simple terms, Newton's second law of motion is F is equal to m times a. Or Newton's second law of motion can also be stated in a different way. That the rate of change of momentum of an object is directly proportional to the force applied. And from the foregoing, we've come to see that force is equal to mass times acceleration, or F is equal to ma. So then where does this bit of momentum come in? First of all, it's important to keep in mind that momentum is mass times velocity. So from Newton's second law of motion, we have F is equal to ma. From our discussion on motion, we came to see that acceleration is equal to change in velocity over time. And the link to that particular video is shown up here. You can check it to get a better understanding of what acceleration is. But from that, we saw that acceleration is change in velocity, that is final velocity minus initial velocity over time. So if we are to substitute that one into this relation, we have force to be equal to mass times change in velocity over time, which represents acceleration. If we are to expand what we have here, we'll have force to be equal to mass times the final velocity minus mass times the initial velocity all over time. So expanding this, we have force to be equal to mass times the initial velocity minus mass times the final velocity all over time. And we know that momentum is equal to mass times velocity. So then from this relation, we see that force here is equal to the change in momentum over a course of time. And that is why Newton's second law of motion states that the rate of change of momentum is directly proportional to the force applied. So we see the force applied here being equal to the rate at which momentum is changing. Let's take it a step further. When we multiply force times time, we are going to get Ft to be equal to mv minus mu. Now, Ft is equal to the difference in the momentum, mv minus mu. This relation, this part of the equation, F times T, is referred to as impulse. So please keep it in mind, impulse is equal to the difference in momentum, because Ft is equal to mv minus mu. From Newton's second law of motion, we know that the rate of change of momentum, which is mv minus mg over t, is equal to the force applied. From what we see on the screen, if momentum is equal to mass times velocity, then it means momentum would have a unit of kilogram meter per second. Because mass is measured in kilogram, velocity is measured in meter per second. What about impulse? From this, we can clearly tell that impulse is also going to have the same units. Impulse is also going to have the same units because impulse is simply changing momentum. And so impulse would also have a unit of kilogram meter per second. Or you can look at it differently. Force has a unit of Newton. Or from this, we know that mass is measured in kilogram. Acceleration has a unit of meter per second squared. The derived unit for force is kilogram meter per second squared. The one we commonly use is a Newton, but it can also be expressed in kilogram meter per second squared. Therefore, if we look at the impulse relation here, which is force times time, force is measured in kilogram meter per second squared. Time is measured in second. Therefore, when we put these two together, we are going to end up with kilogram meter per second. I hope you enjoyed this tutorial. Thank you very much for watching. Please do not forget to subscribe, leave a like or a comment. See you in the next presentation.